Okay, so I have 3 examples. Go through those real quick and we'll be good. Um, Sorry. Oh. All right. What elimination is the one where you multiply your equations by numbers so that you can add them together and get rid of a variable. So you pretty much choose a variable you want to get rid of, and then you want to make it so that the variable has the same number but different signs. So for example, if I wanted to get rid of the x, I would want a number that both 2 and 5 would multiply to. Yeah, 10 would be the easiest. So I would need to take this equation times 2 and this equation times 5, but I need one of them to end up being negative. So since they're both positive, I would need to take one of them times a negative number. So let's see. And then you just need to make sure to take your entire equation times that number. So this equation will become that. Bottom equation. And then when we add the two equations together, the x's would cancel out. So we only have one variable. So then we can solve it. Then you go back and you plug that in. Again, it doesn't matter which equation I choose. I'm going to choose the second one just because it looks like it has smaller numbers. And you figure out what x is. All right, so that's elimination. Again, even though this section doesn't have the x squared problems, you could still use it with the x squared problems from last section. Okay, so example 2, if we work through that one, so I could just multiply the top equation times -2, or sorry, just times 2. So everything on the left-hand side would cancel out. And I get 0 equals 7. So what does that mean? No solution. Graphically, again, what does that mean? Yeah, it means your two lines are parallel. It means you have two lines that are not intersecting at all. Yesterday we talked about, with our others, that might meant that we have a circle and a line that were not intersecting. Okay, so what if you were solving this? So this would be something separate. But what if you were solving something similar and you ended up with something that was 0 equals 0? What does that mean? Yeah. Infinitely many solutions. Now, it doesn't mean all solutions. I've seen some people put all solutions before. It doesn't mean all. It just means infinitely many. And again, graphically, that means you have the exact same equation, so it means you have the exact same line. Or if we're talking about the conics like we were doing yesterday, it means you have the exact same circle. So just adding this on because we didn't talk about this yesterday. I forgot to give you an example like that, so I want to make sure to do an example like that today. What? I'm adding. You could subtract. We always try to get opposites so we can add. Every time I've ever had anyone subtract these, subtraction always causes so much more issues. Because whenever you start subtracting, people mess up signs and other things, so it's so much easier just to always add. Do you have a question, Taylor? No. Okay. Okay. One more, which we kind of already covered today. What do you do if you end up with fractions and you have some uglier fractions today than you did yesterday? So with the fractions today, it becomes even more of an issue to get rid of your fractions than it was yesterday. So this one you'd want to take a couple steps. So what do you want to multiply this by first? 6 would be, yeah. I mean, you could multiply it by 2 first, but in the end you'd end up multiplying it by 6. So wherever you do that, the 2 would cancel out with the 6 and leave a 3. The 3 in this one would cancel out with the 6 and leave a 2. So then let's simplify this, because this is going to be a lot different looking equation than it started off looking like. If I have minus 3 and plus 4, what do those become? 1. Okay, so then I subtract 1 from both sides. Okay, so then do I need anything else to get something to cancel? Nope. But notice that equation does look way different, because in the beginning it looks like we could get the x to cancel out pretty easily because we just have an x and an x. But it ends up it's the y that will cancel out easily. Yep. We did that on the last one too. So on the last one, we just multiplied the top one by 2. We didn't multiply the bottom one by anything on the last one either. Okay, so x equals 7. Put that back into one of the equations. So I'm just going to use the second one there. So 7 minus 2y equals 5. So negative 2y equals negative 2. So y equals 1. All right, there you go.